So now let's take a look at question 22. So if the series, the summation from n equals 1 to infinity of an equals to capital A, I'm assuming it means it's convergent. And so if you're given that, and you're given this right here, let's write this a bit better. Yeah, and you're given that the series Bn from n equals 0, summation up to infinity equals to capital B, then the series from n, or series or summation from n equals 1 to infinity of an times Bn equals to capital A times capital B. All right, let's take a look at the solution. And also note this is the last question of the quiz. So this is actually false. So this is not true. And let's use some basic geometric series to test this out. We could just test, because remember, all we need is an example to show that it's false. So let's go over an example, a simple one here, like this. So an equals to 0.1 to the power of n. And so let that let the an equals that, and let bn equals to, well, 0.2 to the power of n. Yeah, so these are just geometric series. So then we have this. We have the summation. So we have this summation as from n equals to 1 up to infinity of 0.1. You could also 0.1 power of n. And just for completeness, to make it look like the geometric series in the theorem, so you could write this as n equals to 1, and then remove this out. So 0.1 times by 0.1 n minus 1 is power 1. So when you add those up, it's the same thing. Yeah, for example, if you plug in n equals 1 inside here, it just goes 0.1 to the power of 1, that's 0.1. If you plug it in here, it goes 0.1. 0.1 power of 1, that's just 1. But that's just 0.1. And then times it by 0.1, and then n minus 1, so 1 minus 1 is 0. So anyway, just for completeness. So this equals 2. We know this is going to be a 0.1. This is a. So this is our a, and this is our r. So they're both the same. So this is going to be 0.1 over 1 minus 0.1. So this is going to be our a. That's going to be our r. So they're both 0.1. And this equals 2. 0.1 over 1 minus 0.1 is 0.9. So you can multiply it by 10 on both sides, and you'll notice that this will cancel out. Yeah, or you could just do that in your head. It's going to be just 1 over 9. So 0.1 divided by 0.9 is just going to be 1 over 9, and this is our equals to our a. All right, so that is for this one, for a. And now let's look at the second one. So then, and summation from n equals 1 to infinity of bn, let's go put this here, 0.2 to the power of n. This equals to, well, we could do the same thing over there, and it's going to be the same thing. It's going to be now 0.2 over, that's going to be our a, and this is going to be 1 minus r, which is going to be the same thing. R, because again, it's the same thing. We could separate it out, and all we're doing is replacing a 1 with a 2. Alright, and this equals to, well, 0.2, divide this by 1 minus 0.2 is just 0.8. 0.8, so this equals to 2 over 8. This, and then you can cancel this as 1, that's a 4. And this becomes 1 over 4. This is our B. Now let's just box this out. So that's our B. So B is 1 over 4. A is 1 over 9. So together it should be 1 over 9 times 1 over 4. That's 1 over 36. We'll get to that in a bit. So thus, yes, we have that. Thus, now let's do the actual multiplication of the series. Thus, summation from n equals 1 of infinity. Now, if you multiply these two terms together, you're going to get 0.1 power of n times by 0.2 to the power of n. So an times bn, just to get it like this. This equals to, well, we can simplify this right here. Yeah, let's go here. So let's do some algebra. So this is the same thing as writing equals to, well, 0.1, the same power. Yeah, we could take this n out, make it outside of them both, or instead I'll just put it all together here. Just make it all neat over here. So n equals 1. This equals to 0.1 times it by 0.2 power of n, like that. And this one right here is 0.1 times 0.2. That's just equals to, well, 0.2 divided by 10 equals 0.02. So again, it's going to be another geometric series. So this equals to, like a summation, and move this down here. Scroll down here. It's going to be summation. Try this a bit better. From n equals to infinity. This is from n equals 1 to infinity. From n equals 1 to infinity. And this is going to be 0.02 to the power of n. Yeah, the power of n, like that. And now we can do the same thing, the geometric series sum. So a divided by 1 minus r. And this one, a, is going to be, well, 0.2. So this equals to, let's move this all over. Oops, I'll move this over. Okay, move it over to here. So this equals to a minus, yeah, it's going to be 0.02. This is our a. Divided by 1 minus r, which is 0.02, which is also a. And this is, yeah, it's also a, this is also r. So this is our r. This equals to 0.0, yeah, this just equals to 2 over, 0.02 over 1 minus 0.02, that's just 0.98. And here, if we just multiply by 100 on both sides, this equals to 2 over 98. And then divide by 2 on both sides equals to 49 times 2 is 98. So 1 over 49, like that. All right, so that is what this multiplication equals to, but now if we do a times b, this equals to, well, we know a is 1 over 9, b is 1 over 4. 1 over 9 times by 1 over 4, this equals to 1 over 36. Like that. And this is not equal to, so these ones are not equal to each other. These ones, like this, so this is not equal to this. Not equal to each other. So this is, hence it is false. So hence this does not always, it's not always the case. You can't just make this, so that's not a theorem, that's just a false statement. Because it doesn't have to be true, as this example shows. So it's very, very interesting stuff.